Good morning and welcome to Manitowoc Ice's monthly webcast. This is June 2023. We're going to be talking about Neo safety limits and troubleshooting. My name is Aaron. I'm a technical training specialist here at Manitowoc Ice. Thank you for attending. So we'll get started here. First thing I want to point out is there's a question mark tab in the upper right-hand corner of your screen. You can click on that, type in your question. And there's people in the background live, real time, that are waiting to answer them. So feel free to question or comment. And for those of you who have done this before, you'll also know that there is an opportunity to take a quiz at the end of this presentation. There'll be a QR code, also an URL in the chat function that we will add. You click on that, enter some basic information, mainly your email address, so we know how to get a hold of you. Finish the quiz, click submit, and you will be sent a PDF version of both the PowerPoint and that certificate of completion. So to get started, service LED, control board LEDs. There's two ways that we can tell what safety limit we would have stored in our control board. First way would be to turn the power button off and back on again. That would work for both actually. But that's the first thing we're going to want to do. And then you're going to want to look at that service wrench LED that's on your touchpad. It's going to flash. One flash correlates to safety limit number 1. 2 flashes would correlate to safety limit number 2. 3 flashes are going to correlate to safety limit number 3. Now there are also LEDs on the control board, safety 1 and safety 2 LEDs, depending on which safety limit you would have. The service limit 1 would light up, service limit 2 for safety 2, or both 1 and 2. If both of those are lit up, that means we have safety limit 3 stored in the control board. So what are those safety limits? Well, they're going to correlate to what's pretty common with the rest of our product line going back decades. Safety 1 is going to be our long freeze. So it says 35-minute freeze cycles here, but that's going to be dependent on what software version you have, and we'll get into that in a subsequent slide. But after 3 consecutive 35-minute freeze cycles, if you have the current software, the ice machine is going to record a safety limit number 1. That SL1 light is going to, LED light's going to flash on your control board, and the wrench light's also going to flash off and on in 1-second intervals. If we get 6 of these long, consecutive long freezes, we are going to go into a shutdown. The machine's going to shut off, and we are going to flash again the safety 1 LED and the service wrench on the user interface. Safety 2 correlates to long harvest. If our harvest time reaches a maximum of 7 minutes, the ice machine is going to initiate our thaw cycle, flag that harvest limit, store that in the control board. If we have 3 7-minute harvest cycles in a row, we're going to finish up that last thaw cycle. We're going to go into a shutdown, and we're going to flash both that service wrench LED on the user interface and also the number 2 LED on the control board. And one thing that's important to note is that either one of these safeties are going to be stored in that control board for either 100 consecutive good cycles or until it would be overwritten by a different safety limit. So the machine could be operating fine. Maybe we fixed it, someone didn't clear out the board, or actually there isn't a way to clear out the board except for what I just said. You'll still see that service limit. That's just stored in there just for reference in case you need to go back and figure out what may have been happening in the past. So just remember that if that light's flashing, it doesn't necessarily mean that the machine's not working. It just means that there's something stored in the memory. So if we want to check what's stored in the memory, again, we would just turn the machine off, back on again, no different than any other. If we were trying to find a service limit, and it's going to flash whatever corresponding service limit would be stored in the memory. You might also see the service wrench blink too on the user interface. Safety number 3 is going to be our water loss safety. That one's a little bit different than, say, Indigo or some of our older product line. That's basically saying that the low water float or the harvest float did not rise. That's what tells the control board that, hey, water actually is in the machine within 4 minutes of that water inlet valve energizing. So if that happens, we're going to flag safety limit 3, of course, Both the service safety 1 and safety 2 LED on the board is going to flash, and the service LED wrench light will flash over and over. It's going to shut down. It's going to attempt to restart in 30 minutes. Maybe the water problem has corrected itself, or someone turned the water back on, for instance. It's going to continue to try to do that for 100 consecutive cycles. If after 100 cycles we still don't have water to that machine, it's going to go into a shutdown state. Now, if we're in that 30-minute delay period, we can override that simply by turning the machine off and back on again. So, Neo safety limit 1, long freeze. Again, I talked about what the freeze cycle timers are, depending on what version of software you have. Remember, we have made revisions throughout the years. Initially, with the original software, we started with a 60-minute freeze time. We determined that was just way too long. If you can't make ice in 30 minutes, you're definitely not going to make it in 60. So we shortened it up to 45 minutes. And then now on our current software, starting with software version 3, we're down to 35 minutes, and that kind of correlates to the rest of our product line just to make it more uniform. So keep in mind that depending on what machine you're working on, long freeze, the amount of time that actually is, could be different depending on what version of software that you have. Now, if we need to find out what version of software we do have, it's pretty simple. You just need to get access to the control board. Fairly simple to do. You just take off that front louvered panel. There's a metal cover over the control board control cavity. You just take that off. There's your circuit board. Remember, there's voltage there, so you probably want to do this with the machine that's unplugged. There'll be a sticker over the relays, the 4 black relays in a row on the control board, pretty hard to miss. And right in the middle there, it'll say SW. The numbers after that are going to correlate to what version software you would have on that machine. It's also important to note that we cannot update software on the Neo product line. Unfortunately, that is not a feature set like that is available on the Indigo. There is no way to field update the software. The only way that you can get the current software would be to buy a new control board. So a few causes that could lead us to safety limit number 1. Of course, refrigeration system or electrical, there could be a problem there, but we always kind of want to start with the basics, the simple stuff. Let's not just assume that we automatically have a refrigeration problem. There could be something simple going on. So our water level could be too high, or we have a defective float switch. So what that's going to do is just bring in fresh water constantly. It might overflow the trough. Again, that's going to be heat load that the machine's not designed for. It's designed for 1 trough of water. It's a batch system. So if we're constantly bringing in too much water, that's going to affect our ability to freeze. We could have low water pressure where we're not getting enough water. Remember, there's a maximum fill time. So if we exceed that, it's going to stop no matter how much water is in the machine. So if we have too little water, we're not going to have a very good ice sheet. It's not going to freeze properly. High water pressure. There again, we're going to bring in too much water. That water inlet valve is rated for 80 psi. If we go above that, we could push through that valve mechanically and continue to bring in fresh water all the time. We could have too hot of water temperature. Now, for those of you down south, you might see this in the middle of summer where you do actually have 90-degree water. Your pipes down south aren't buried very deep, so they can warm up during the day, of course. For those of you in a northern climate, you're probably not going to see too much of that. Here in Wisconsin, where we're located, we bury everything below the frost line, so our water temperature seems to run a consistent 50 to 60 degrees. So not a problem in the northern climates, but down south, that could very well be a problem. Clogged water distribution tube. We're not getting water over the evaporate period. You're not going to make ice without water, of course. Dirty, defective water inlet valve. We're just not getting water in there to begin with. Or a defective water pump. If we're not pumping water over the evaporator, of course, we're not going to be able to make ice. So we want to kind of check the obvious things first before we jump to conclusions. Now we could, like I said, have an electrical system problem. We just might not see that harvest cycle being initiated. That low float might not be working correctly, telling us to go into harvest. So of course, we're going to time out on long freeze if that float never makes or the board never knows that we need to go into harvest. Our contactor could not be energizing. Of course, then our compressor is not going to start. If we don't have a compressor running, we're not going to make ice. Defective fan cycle control. Yes, if our condenser fan's not working, that's going to greatly affect our refrigeration cycle and could go as far as the fan motor itself not working. Refrigeration system, of course, we could have a refrigeration problem. Non-Manitowoc components, this is something I like to bring up a lot. We only endorse the use of OEM components. The reason we endorse these components is because we test them, we verify them, we make sure that they're going to work in their application. So if you're putting in non-standard parts in your machine, that could definitely have an effect with freeze cycle, harvest cycle, refrigeration in general. So please only use OEM components. We could have a refrigeration charge problem. We could be low on charge. Of course, that's going to affect our capacity and the ability of the machine to make ice. Could have a defective compressor or a weak compressor that might be functioning correctly in a lower ambient. It gets warm, it has to work harder. Maybe that compressor doesn't quite have the capacity it used to. It's worn out. Starving or flooding TXV valve, check that bulb mounting. We could have a problem with the TXV. If that bulb's not correctly mounted, it's going to flood the evaporator. So we want to check over that. We could have non-condensables in the system, especially if you didn't take your time and make sure that we're leak-free and that we pulled down in a good long vacuum. Non-condensables absolutely wreak havoc on a refrigeration system. They cause high head pressure problems. So that's why it's always important that you do a good job when you're evacuating, fixing leaks, and pulling a vacuum. And we could also have a defective harvest valve, perhaps one that's stuck partially open where we're dumping hot gas into the evaporator constantly. So there's a lot of things that could be going on. Start with the basics, verify our water, not only pressure, but flow, make sure we're getting the correct flow. Make sure that our harvest float's working and that we're initiating a harvest to begin with. Some basic stuff here. So let's go into a scenario and how we can troubleshoot and kind of work our way through this. So here we have a machine that's making ice. We can see from this picture, we have a nice sheet of ice that's formed, but it still is not going into harvest. So what could, or what is causing this? If we have a full sheet of ice on the evaporator and the empty water trough, we're gonna have to look to the board to verify what part of the sequence that we're in. So if you can see on the screen here, we have a picture of the control board itself. You can see that harvest light. You can also see that low-level float light. So that low-level float light is going to be your harvest light. When that low-level float drops, it turns that light off. So if that light is on, that's saying, or that's the control board is thinking that that low-level float is still not made. It thinks that there's still water in there. Of course, that low-level float is when it's going to initiate our harvest. So clearly, if we do have that sheet of ice and we have an empty trough, we want to first verify that that float is actually mechanically down. Maybe it's stuck and might need to be cleaned. Could have a dirty machine. Again, I've said this many times before and we'll say it again. Dirty machines cause all kinds of problems when it comes to ice machines, so make sure that machine is clean to begin with. But we want to verify that that float is actually in the down position. So go in there, take a look, maybe wiggle on it. If you're in fact all the way down with that float, we're going to obviously have a problem with the float itself. We can easily test this. There's two ways that we can do this. The first way is probably the easiest. We're just going to pull those wires through into the evaporator compartment. You'll see the two red wires there. We're going to jump that float out. What that's going to do is close that circuit, and that's what the control board's looking for. That light should go off at that time. And that should initiate the harvest. If the light still doesn't go off, we're probably going to want to go back to the control board itself, jumper the connection right at the control board. That should eliminate all the wiring, the float in general. If we still see that light not going off, if it's still staying on, we have a problem with the control board itself. Something is wrong with the circuitry inside the board. We're going to have to replace that board. But more than likely, what you'll find when you jump out this contact, you'll find that you have a faulty float. Or you have a sticky float, could be mechanically sticking. Situations like that, clean that float off. If that doesn't help, we're going to want to replace that float. Once that float contact makes and that light goes out, we should go into harvest and that sheet should drop. So that's one scenario that you can run into with long freeze. So moving on, safety limit number 2. Long harvest. What are some common causes for safety limit number 2? Well, we'll see a few of these are kind of the same as long freeze. The first one's going to be a dirty ice machine. Again, I just said it, dirty ice machines cause all kinds of problems. So if the evaporator itself is dirty, a lot of scale, slime deposits on it, that actually holds on to that ice, and it's going to act like sandpaper friction, and it's going to have a hard time dropping that sheet of ice off of the evaporator. So first thing we want to do is make sure that ice machine is clean. If we're having issues with long harvest, first thing we want to do, go inside, take a look, make sure that the evaporator is clean, that the whole machine itself is clean. We could have a dirty defective water dump valve. That's going to essentially never dump out water. We want to dump out that water at the end of the freeze cycle. That's our most heavy mineral laden water, dirty water. What that does is it just keeps that in there over and over and over. We never purge and flush out that water. That dirty water can actually start to form deposits and whatnot on the evaporator, causing trouble. So water dump valve, believe it or not, can be an issue here. Water freezing behind the evaporator. So if the evaporator is not mounted correctly, what have you, we can get water behind the evaporator. That's going to actually start to form and bridge across the evaporator, and that's going to hold that ice on. So no matter how much or how long we stay in harvest, we won't be able to break that bridge and get that ice to fall off. Plastic extrusions and gaskets. Again, this is going back to an evaporator that's not mounted correctly. Basically, that water is going to start to freeze onto those extrusions and hold that ice sheet on. We could have low water pressure, so not enough water to form a nice heavy sheet to get that to drop off with gravity. Again, loss of water from the trough. That would be similar to low water pressure, just not enough water to get that nice thick sheet of ice that helps us with gravity and weight to pull off the evaporator. Dirty defective water inlet valve. Again, we're not bringing in the proper amount of water to make that proper sheet. Electrical system. We could have an electrical problem, of course. The big one here is going to be our bin switch failing, or a harvest cycle initiated prematurely by a float switch that has flaky contact, so it's going into harvest too soon, not freezing long enough. Again, a water inlet valve that's defective electronically. Refrigeration system, again, non-Manitowoc components, only use OEM stuff. We can only guarantee that the OEM components that we tested are going to work properly. Improper refrigerant charge, of course, if we don't have enough refrigerant, we're going to have trouble harvesting. We're not going to have that heat and energy there that we need to get that ice sheet to melt. Defective harvest valve. Could be defective electronically with the coil, or it could be defective mechanically. It might not be opening all the way, closing all the way, or staying partially open. TXV flooding, of course, we're going to want to check our bulb mounting there to make sure that we have that mounted correctly. Or we have a defective fan cycle control. If the fan's not working correctly, we're not going to have, or if it's staying on too long, etc., we're going to have issues with our refrigeration cycle. Couple scenarios that we can run into here. We'll go through real quick and how to troubleshoot them. If we have a safety limit 2 or a long freeze, say we have an ice sheet that's not dropping, but the cubes aren't melted. It's like there's no heat there to begin with. If we can get a cube or pry that sheet off and we see that those cubes are nice and firm and there's no melting going on, we can pretty much rest assured that there's just no heat going to it. So where are we going to go from there? Well, the first thing we're going to want to do is make sure that we did, in fact, initiate a harvest cycle. So we're going to want to take a look at that board, look for that low-level float light to be off and that harvest light to be on. Notice that we have an LED for the harvest function. That's what lets us know that we're in harvest. Is that light on? Are we in harvest? Do we have voltage at the board to the harvest valve? Okay, so we're in harvest. We see that LED. We're rest assured that we're in there. Now we're going to start looking towards that harvest valve. So we're going to want to probe for voltage at red wire number 6, blue wire number 2. Blue wire number 2 is going to be neutral. Of course, the red wire is going to be what's supplying power to that valve. We're going to look for voltage to it. Do we have voltage going out to that valve? Another trick that we can look for, another tidbit here that I can talk about, is that condenser fan. In harvest, that condenser fan on a self-contained air-cooled generally should not be running. If we see that condenser fan is running during harvest, there's probably something going on there, and we'll talk a little bit about that in the next slide. Another thing we can do is compare the temperature of the discharge line and the harvest valve inlet. So if that harvest valve is open and we're directing discharge gas into it, we should see that the temperature at the inlet of the valve and the temperature of the compressor should be roughly the same. Now be careful, it's going to be warm. It's not going to be so warm that it's going to burn you immediately, but it's not something you're going to want to hang on to. But if we see that there's a temperature difference there, we can kind of form a conclusion that there probably isn't either enough gas flowing through it or any at all. It could not be opening. So that's a general rough indicator. What we're going to want to do at this point is we're going to want to gauge up, get our refrigeration gauges out and gauge up and kind of get an idea what's going on during harvest. So obviously we have our pressure chart here, and we also have the fan cycle control specs, and I'll get into what that means. But with our gauges hooked up, we're going to want to take a look at what our pressures are in harvest. If we're seeing high head pressure and low suction, we can guarantee that that harvest valve is not opening. As you can see, when we go into harvest, regardless of the temperature, our head pressures drop way down and our suction pressures start to come up. So if we're seeing basically a continuation of free cycle temperatures in harvest, we know that that valve's not opening. I also talked about that fan, condenser fan running during harvest. As you can see, the cut in and cut out pressures of that fan cycle control are almost always, in most ambient temperature conditions, above what the harvest cycle pressure should be. So if you see that fan running on a self-contained air-cooled during harvest, that's another indicator that we have a problem with that harvest valve. So we're going to want to make sure to verify electronically that we got, like I said, voltage in the previous slide, voltage going to that valve. We want to make sure that the coil on the valve is good. If those all check out, we're going to want to replace that valve. We always recommend that we replace both the coil and the valve at the same time, just to make sure that we rule out any intermittent problems that we may have with either one. Another scenario that's pretty common that we run into with the Neo line with long harvest safety 2 is going to be our damper switch, bin switch, damper switch. If that damper switch doesn't open when that sheet drops and opens up that damper, the board doesn't know that that sheet actually dropped. It won't know that the harvest cycle is completed. So we want to verify that our damper switch is working. There's 2 ways we can do that. I like to use the meter way, disconnect the connector off the control board and actually use an ohm meter. So I get a very definitive result. When that switch is closed, we're going to want to see less than 1 ohm of resistance, very little resistance. When that switch is open, we're going to want to see open line on our meter or infinite resistance, stating that that contact is open. And it's important that we do this numerous times, 20, 30 times. What we were looking for here is consistency. We want that each and every time to switch state when we open and close that. Now, as you can see, there's also an LED on the control board, and there's also an indicator, the bin full indicator on the user interface itself. Now, I guess we could do the same thing. We could flap that damper open and closed, watch those lights, make sure that they're turning on and off. But I really do stress to try and use a meter, because that gives you a very definitive, it'll help you to see some small discrepancies or some intermittent issues that LED on the control board and the LED bin full light might miss. So like I said, try to use a meter, get right down to that connector, ohm it out. Of course, if we find a faulty one, we're going to want to replace it. If 1 time out of 30 it doesn't switch state, that's enough to say, oh, there's a problem, intermittent problem. Let's get a new switch in there, start over, and that should take care of our issue at that point. And to move on to safety limit 3, or water loss, our last safety here that we're going to talk about today, that's stating exactly what I just said, that the machine is not sensing that low water flow rising within 4 minutes of energizing that inlet valve. So the machine at that point is going to think that there's no water in the trough. So a couple things we want to do is verify our incoming water supply, especially if we have intermittent issues. Make sure our water pressure is at least 20 psi. So you never know, someone could turn the water off when they go home for work at night. They might not realize that the valve they're turning affects that machine. So the number 1 step here, let's check our incoming water supply and just make sure that we have the proper water supply to begin with before we start troubleshooting anything else. If we're rest assured that we do have proper water supply, we got nothing going on with that, pressure checks out, we're going to be looking for voltage at the board for the water inlet valve during pre-chill and the beginning of freeze. So we're going to want to probe for voltage at the connector, and I'll show you how to do that in the next slide. And make sure that we're in the right step of the sequence of operations though. So you see the energized chart that I have up here. That's going to tell us when each and every component is supposed to be coming into play. So if we forget and we don't remember where we should be, all we have to do is find our technician's handbook, the most important tool in our arsenal, look up this energized chart, and we can figure out where we need to be. So pre-chill and the beginning of freeze is when that water inlet valve is going to be working. We also need to verify that the dump valve is closing. So if that dump valve doesn't close, we're just going to continually drain water out. It's going to pump it right out. So we need to make sure that that dump valve is closing, and we'll get into how to troubleshoot that in the next slide. So water inlet valve diagnostics. We're going to want to check for voltage at the white wire number 42 and the blue wire number 2. Again, blue number 2 is going to be our neutral or common. Now, we have had some minor changes that have come up as far as wire coloring goes. Supply chain is still an issue, probably will be an issue for years going forward. So I like to stress wire numbers over wire colors. The colors are fairly consistent, but I have seen a couple changes. So just keep in mind that the wire number will never change. The wire color could. So I always stress to use the number of the wire over the color. And of course, we can find these diagrams in our technician's handbook. Those are available online for free. You can download them from our service tab on our website. So white wire number 42, blue wire number 2. If we are in pre-chill and we are or in the beginning of freeze, we should be seeing line voltage there. If we are, it wouldn't be a bad idea to go right to the valve itself to make sure we don't have any breaks in the wiring. It's just a lot easier to check at that front connector. We don't have to take the bin off necessarily. But if we're seeing voltage there, it wouldn't be a bad idea to go back to that valve, make sure that we got voltage there. And always make sure that we're in the right step of the sequence of operations, because this valve is not always energized. If we're seeing voltage at that valve, still not opening with verified water supply, at this point it would be time to replace the valve. Very similar for a water dump valve, except we're going to be probing for voltage at orange wire number 37 and the blue wire again, number 2 common. We're going to be doing that during freeze cycle this time because I want to see if we have voltage when we shouldn't. So during the freeze cycle, if we go back to that energized chart, we saw that dump valve should not be energized. So if we're in the freeze cycle and we're probing for voltage at that board connector and we see voltage there, maybe we see voltage all the time, doesn't matter what state the machine is in, we got a problem with the control board itself. If we don't have voltage there, we're not going to have voltage at the valve. We can pretty much rest assured that if we see leakage going through that valve, even with voltage not applied to it, we're going to want to replace the valve. So very similar, we just have to be careful of when we're probing for voltage. It's going to be at a different time when we expect to see voltage and when we don't expect to see voltage. And that kind of concludes the technical aspect of our webcast today. There's a few things I do still want to bring up. Again, level 3 factory training. We probably say this every time. We like to give a shout out. We have some dates planned for the fall and winter. If you're interested in signing up, just go to the service tab on our website, look under training, Manitowoc level 3 factory school. You'll see the registration form that can be downloaded, and you'll also see those dates. Still openings available, so feel free to sign up. We also have expanded our schedule here for upcoming webcasts. Of course, this is June 2023, so that shouldn't be up there, but July 2023, we're going to be talking about modular ice machine, not harvesting, and how to troubleshoot that. August 2023, we're going to get into flake and nugget diagnostics. September 2023, Luminice installation and troubleshooting. In October, we'll talk about Ice Tech FAQs. Some of you may know about this already. We're expanding that, and then we're going to do pretty much a hard release, show you what's all available. So look forward to that. November 2023, we're going to get into the Neo refrigeration system and how to diagnose the refrigeration system itself. December of 2023, right before the holidays, we'll be getting into Indigo next, and we'll do a cleaning procedure. Again, for those of you who have watched our webcast before, We have a QR code up here. Now, this is not the quiz QR code. This QR code is for any ideas or comments you may have regarding future content or technical content. We're always open for ideas. We do this for the technicians out in the field. So if you have any ideas, please submit them, and we'll do our best to make that happen. The seminar quiz, like I talked about earlier, we're at the end here. Now, remember, if you want to receive a copy of the presentation and the certificate of completion, you got to hit that submit button, and you also need to put your email address in. If you don't put the email address in, I have no way of contacting you and giving you that stuff. We are also continuing our prize giveaway. A couple simple rules here. The quiz will need to be submitted within 2 hours of the original webcast. So you can take the quiz whenever you want, but if you want to be entered for this drawing, you're going to need to do that within 2 hours of the end of this webcast. Unfortunately, employees of Manitowoc Ice are not eligible for this. Sorry, guys. Only one quiz submittal per person. You can take the quiz as many times as you want, but you're only going to be entered once for the giveaway. Winners will be notified by your email address. So again, please make sure that email address is correct. Otherwise, I have no way of getting a hold of you. And for every 25 quiz submissions, we will draw one name for the giveaway bundle that you see here. If we have 50 quiz submittals, then we will draw 2 names, and etc. Here is the QR code that I talked about to take the quiz, and also the URL. The URL will be posted in the chat function for those of you that might not be on a smartphone. So you can just click on that directly and take it through your computer. You can, it's mobile friendly, so feel free to take it either way. And that is the end of our presentation for June 2023. Again, my name is Aaron. I appreciate you tuning in. Hope to see you again. Have a good day. Goodbye.